Question 3. Let f of x equal e to the 2x. Let R be the region in the first quadrant bounded by the graph of f, the coordinate axes, and the vertical line x equals k. The region R is shown in the figure above, so it's just this whole entire region right there. Okay, write, but do not evaluate, an expression involving an integral that gives the perimeter of R in terms of k. So we want the perimeter of this region. So I'm just going to put P equals for perimeter. Okay, we want all the way around. So I want this part, I want this part, I want this part, and I want that curvy part. Okay, I'm going to do the straight parts first. I'm going to start right here. The perimeter, or the length of that part, would just be 1. The length of this part, since it goes from 0 to k, will be k. The length of this part will just be the y value, so it will just be e to the 2k. And then to get this curve, since it's a curve, we'd want to get the arc length of that. Okay, and the formula for arc length, whoops, I spelled that wrong. The formula for arc length is the integral from a to b square root of 1 plus f prime of x squared. So that's the formula that I'm going to use here. So my formula is going to go, this curve goes from x equals 0 to x equals k, so go from 0 to k. It's going to be the square root of 1 plus the f prime, the curve that is based on the curve e to the 2x. So the derivative of e to the 2x, even though this says e to the 2k, my original function is right here, e to the 2x. The derivative of e to the 2x would be 2 e to the 2x, and then I do have to square that. And then they just asked me to write the expression, so I guess I am done. All right, that part was worth 3 points. If you found the derivative, so if at any point in time you found that f prime was equal to 2e to the 2x, you're going to give yourself a point. I'm not sure exactly. We might have wanted to do like a little side trip and showed that the derivative was equal to 2e to the 2x. I'm safe because up here I put f prime, I wrote my formula, and then down here I plugged it in. So the reader of my paper would definitely know that I knew that was f prime, but you might want to denote it somewhere. So that was worth a point for that. Then you got a point if you have your integral set up, and then if you have a third point if you actually did the rest of the problem. All right, part B. The region R is rotated about the x-axis to form a solid. Find the volume V of the solid in terms of K. All right, so we're revolving it about this way, so it's going to kind of create kind of almost like a lampshade or something like that. You'll notice when I do this, we're going about the x-axis, and it's not leaving a hole at all, so I'm going to be using the disk method. And if you can remember the disk method, I'm just going to write it down here as pi, the integral from a to b, and then we're just going to do r of x squared. So the way that we're going to do this, we're going to get pi. We're going to go from 0 to k. And then my radius is going to be, the radius is being determined by this curve, e to the 2x. So do e to the 2x squared dx. And now from here, it is a non-calculated problem, and they did ask me to evaluate it, so I'm just going to clean it up here a little bit. It'll be pi 0 to k. When I do this, I'm going to multiply my exponents. So this will be e to the 4x. And then from here, I do need to take the integral of that. I do notice that I have an e to a power, so I'm going to let u equal 4x, which means du will equal 4. So I'm missing a 4 on the inside, 1/4 on the outside. So then this leads me, I'm going to come over here, leads me to having 1/4 pi, the integral of e to the u, and the integral of e to the u is just e to the u. So I'm going to have 1/4 pi e to the 4x, and then I have to evaluate it at 0 and k. If I plug k in, I'm going to get 1/4 pi e to the 4k minus, if I plug 0 in, I'll get 1/4 pi e to the 0, and e to the 0 we know is 1. So my final expression is going to be 1/4 pi e to the 4k minus 1/4 pi. All right, that was worth 4 points. All right, we got 1 point for the correct stuff inside of the integral. So if you have this or this, you'd get 1 point. Okay, if you have your limits right, so if you went from 0 to k, give yourself another point. If you properly took the integral or the antiderivative, so if you got this right here for your integral, give yourself a point. And then if you got the final answer, which was this expression, give yourself that final point. All right, part C. the volume V found in part B, so I am going to write that down again. We found that the volume was pi, or 1/4 pi e to the 4k minus 1/4 pi. So that's the volume that they're referring to. And it says it changes as k changes. And we know if dk dt equals 1/3, determine dv dt when k equals 1/2. So this basically, they just turned it into a related rates problem. So we'll basically just take the integral of both sides, the derivative of both sides, and go from there. Okay, the derivative of v is actually just 1, but we do need to put dv dt because obviously this, now we're with respect to time. And then the derivative of this one, remember that the derivative of e to the u is just e to the u du. So the derivative of 4x is going to be 4, so it's going to be 4 times 1/4 pi e to the 4x. But I also have to put dx. Actually, that was a k from my first part, sorry. This was dk, and this I have to put dk dt. And then minus 1/4 pi is a constant, so that will just drop out. So now I'm just going to rewrite this a little bit. I'm going to get dv dt equals, those will cancel out, pi e to the 4k dk dt. And now I'm just going to plug in what they told me. So I know that dk dt is 1/3, and I know that k is 1/2. So I'm going to get pi e to the 4/2, which would be 2, times 1/3. So and I guess I could leave it just like that, or I could, if you wanted me to put the 1/3 out in front, I could do that as well. Alrighty, I get 2 points for this problem. I'm going to get 1 point for applying the chain rule, which I did because I actually took the derivative of the 4k and made it 4. So get yourself 1 point for that. And then you're going to get 1 point for getting this final answer right here. So hopefully you got yourself all sorts of points on this problem.